All right, here we are on day two, properties of waves. And so yesterday we looked at types of waves. We talked about mechanical waves and electromagnetic waves. Your mechanical waves, again, can be transverse or longitudinal, but your electromagnetic waves are always transverse waves. And so we looked at those yesterday. We looked at the definition for a wave. And so today let's dive right in and talk about properties of waves. Now, before we discuss properties, of waves, we really need to talk about the definition for the word properties. The word properties is just another word for the word characteristics. It's what describes the wave. If we were to describe the characteristics of who you are, it might be how tall you are, or your hair length, or maybe skin tone. And so, as we talk, or gender. And so, when we talk about properties, properties are characteristics. So, today we're going to look at some characteristics or some properties that waves have. All right, so when we look at the properties of waves, one of the properties of waves are amplitude. The next property that we're going to look at, we're going to discuss wavelength today. We're also going to look at frequency and wave speed. When we look at amplitude, amplitude really deals with the height of the wave. And so if we have a larger amplitude, I don't know if you remember me slinging the slinky in class, but if we have a larger amplitude, then that means that there is more energy within the wave. If there is a lower amplitude, then there is less energy providing the wave. Again, amplitude really deals with the height of the wave. Again, we like to say from the crest to the rest is what we refer to as the amplitude. Here we have a transverse wave, and just showing us in this transverse wave, the amplitude from the crest to the rest. Over here we have our longitudinal wave, and you can see I've written out here longitudinal. Well, in this wave, the longitudinal wave, we measure the amplitude according to how many compressions. So the compression is then considered to be the amplitude. So not necessarily how many, but the compression itself is the amplitude of the wave. I do believe yesterday I made a mistake when I was talking about how we measure wavelength for the longitudinal wave. The wavelength for longitudinal is, again, from compression to compression. We measure that as the wavelength. Not sure if I got that correct on the day one video. Again, as we look at wavelength being another property of a wave, it describes the distance between two crests or troughs. So here we go. Crest to crest is the wavelength for this transverse wave. Trough to trough is the wavelength, again, for this transverse wave. So either crest to crest or trough to trough. It's the distance between the two. If we have a shorter wavelength, so when the wavelengths are really short and tight together, that means that there is more energy. So if I have a large wave, that means more amplitude, has more energy. So the larger the amplitude, the larger the energy. And if I have a short wavelength, that means that throughout that wave, there is a bunch of energy as well. So here we look over at a longitudinal wave. Again, this is our transverse wave. This is a longitudinal. These compressions from one compression to the next compression is what we are referring to as the wavelength. In the transverse wave, again, from crest to crest or trough to trough is how we measure wavelength. In our longitudinal wave, we are measuring from compression to compression or from compression to compression. That's how we would measure wavelength. Here we have our frequency. Frequency is always measured in, you got it right, hertz. We measure our frequency in hertz. And so the number of waves produced in any amount of time. And so the number of waves produced per time is its frequency. Means this one has a high frequency because we have a lot more waves happening here than we do within the same amount of time here. So a high frequency wave has a lot more waves produced per time. Let's go back there a little bit. A lower frequency waves has less waves produced over time. So the number of waves produced in any amount of time, again, is referred to as our frequency. This is the definition for frequency. And then if we're looking at a higher frequency, again, if it has a higher frequency, more waves over time, that also lets us know that there is more energy traveling throughout that wave. Another property of wave is the wave speed, how fast a wave is traveling. And that's its basic definition. It's the speed at which a wave travels through a medium. Hopefully remember this one. Medium, again, is the matter that the wave travels through. Properties of a wave, let's review that. We have the amplitude from the crest to the rest. We have the wavelength, which goes from crest to crest or trough to trough in a transverse wave. And so again, as we look at this slide, we can see two of our properties. We have amplitude, and then we also have wavelength. This symbol right here is the symbol for wavelength. So when we get ready to look at calculating speed, you'll see this symbol here because we have to do some math there to calculate speed. And so this is when we look at that symbol, that is the symbol for wavelength. And so this takes us then to the end of this slide that talks about wavelength. I'm curious though, when we mentioned speed in class, we talked about what the wave speed is and how it's calculated, if any of you remember. Do you remember how we calculate wave speed? You're correct. That's it. Glad you remembered. When we calculate wave speed, we are multiplying. So the speed is the wavelength times the amplitude. All right, that concludes today's very short lesson, just reviewing our properties of waves, looking at amplitude, wavelength, frequency, and wave speed. Please now go ahead and complete the assignments that have been assigned for you on Google Classroom, and I'll be back in with our instructional video, part 3 of waves, interactions of waves tomorrow. Have a great day.